Hi, today we're going to talk about is human trust enough? And we're going to look at it by looking at some metrics because that's only fitting within a Datadog conference. My name is Patrick Dubois and I currently work at Sneak. Some of you might know me from my tweets and my sharing around DevOps and DevSecOps, and these days I'm working a lot around DevSecOps. This is a curated content presentation, so there's a lot of stuff that I borrowed about other smart minds, but I'll give it my own narrative, and be sure to check out the links of any of the presentation that I mentioned in this talk, because they will give you like a deeper content than I will give in this 30-minute presentation. Let's start a story. Yes, developer gets a request from the business. I need to get feature X implemented. What's the number one first reaction the developer has? Being lazy, npm install a feature, right? We're so focused on reuse to go faster and faster and faster that this has become like a second nature, hopefully for a lot of you that think like it's smarter to install something that somebody else wrote. It's probably going to be more secure. A lot of other people have been looking at it. So, why not? Why do I need to reinvent the wheel? But one of the things you get when you install a dependency as simple as one, you're going to get maybe a lot of other dependencies. This is the average report of dependencies that you will get from either direct or indirect libraries when using npm, Ruby gems, and so on. This graph, by the way, is part of the Sneak open source security report, so you can look at that full report in the link. So one dependency, many dependencies. That's where we are at. And it doesn't stop there, because if you take a broader perspective, dependencies are everywhere. npm install might install you the library, but what about the runtime you're running it, like Node? That has versions. And then the distribution you're running things on, that has a version. And if you're using a SaaS, again, more versions, and they're actually all dependencies. You might not consider them, but they're all dependencies. And then how you build whatever you're building, the whole toolchain is another dependencies. Might be second order, but it can introduce new vulnerabilities, as easy as Git having a vulnerability. So more dependencies. And dependencies, they bring in the risk. Good quote, a clear quote by Dan Geer, known in the security field. Risk. And in our study, we found that people don't deal too well with all these dependencies. You might be good at dealing with the direct dependencies, but what about the indirect ones? And maybe I don't have time to do all these dependencies. So the moment that you select a library, a lot of people don't put enough work in there, like vetting a library. So they might check a few things, like the research has shown. Is there an active community? Makes sense. Are there many releases and commits? Just to get a better feel. Obviously, we want to know that there's no vulnerabilities, because that would be a bad thing. We want to have a feature. We don't want to have all the vulnerabilities that come with it. Overall, when I looked at all the different ways that people were vetting kind of their libraries, there is 4 main areas. One has to do with competence. We look at different technical stuff, like the number of tests, because then gives us the idea how competent the library is. Or we might even read the source code, we look at the number of issues, look at the technical documentation, and it all gives us a feeling of how competent this library is. We also look at how reliable, like the number of latest commits, is it still releasing, is it reliable? So if it gets a lot of stars on GitHub, it might give an indication that it is reliable because people are happy with it, right? And so if there's more articles around it and people are happy with it, it gives us a sense of reliability. Then we look at the third one, how sincere is the library? So does it change what it promised to do? Did it change kind of does it clearly state the changes in the change log? Is it open how it builds things, right? So it has nothing to hide. It's sincere, it's in the open, how the library works. And then the last one is, we might be competent library, we might have a sincere library, and a reliable library, but does it even care? At a certain moment, maybe they don't care about the pull request, they don't care about the community, and they might start using abusive language. So that is a care factor. So 4 different areas to look at. Lots of different aspects that we're not like immediately aware of when we do these things. A lot of it is unconscious, but they do make into account of selecting a library. And those 4 areas, I didn't invent them. Like I said, like I rely on a lot of other people's ideas. It's coming from the Tin Book of Trust. And it shows you that the human trust, or trust in general in something, comes from these 4 areas. So we kind of might weigh them differently. So engineers might look more at competence and they care less about reliability. But in the end, all those 4 factors will influence the trust. And depending on whether the library is delivering on all of those 4 areas, we might gain or we might lose trust in the library. And what we realized about that is that by just looking at a technical library that we wanted to have for solving a feature, we're actually looking at people, at all those dependencies, whether it's your cloud provider, whether it's the distro provider, whether it's the package, they're all people behind it. And they're doing their best on helping you in getting that feature implemented. And so another way of looking at it is that they're actually part of your delivery pipeline. You might not consider them because they're like dependencies, and you don't take them into account while you're looking at a pipeline, which is like very rigor, and now we got dev and ops and sec working together. But there are dependencies, and they have their own pipeline, their own delivery cadence, their own testing before coming into your pipeline as well. And face it, a pipeline is 99% human, right? So we might automate a lot, but a lot of the discussion is still going. And open source, particularly, having a history of working from remote, you would see a lot of it happening in pull request issues, discussions. A lot of the GitOps is kind of inspired of capturing that kind of discussion in a good way. But the difference between traditional thinking of dev and ops is that now with the unity of dev and ops, they're under the same control. They're within the same company, where all of those dependencies are outside our control. So we might try to get people again under control by, maybe you kind of hire the maintainer of a package, or you buy a library license, or you buy a service contract to the SaaS provider. But in most of the time, they're outside your control. And that is a very hard differentiator with what people traditionally think of dev and ops inside their own company. And this reminded me of promise theory. Promise theory, known by Mark Burgess, that is about like scaling human systems and scaling computer systems in a similar way. And the idea is pretty simple. Like, everybody is an agent. You're an agent, the library is an agent, the maintainers of the distro are maintainers, we're all agents. And we all make promises to other in the systems. And while within your DevOps kind of inside your company, you might take a promise as something for granted, or where we align everybody to, it is different, because a promise does not guarantee an outcome. So we're in the idea that we're gonna give you a promise, but we're allowed to fail. And that is a different assumption than it is totally controlled. And open source and all the other dependencies are a promise. We cannot guarantee that. And so we depend on all these other agents to keep our own promises. But what we can't do is, while they are making promises to you, we cannot make promises on their behalf, right? If you want to say the whole system is secure, we can't do that because we can't promise that they are secure. That is part of our job to do that and kind of either have it by conversation or alignment of goals to make sure that we hit those targets. But we have to be aware that they're all promises. And the important part is that you might depend on them, but you have to make sure that you're not dependent on them as the only one. So there are options, like I told, you kind of have multiple libraries, you write abstraction layers, but then you need like redundancy of abstraction layers. So there's a lot of work you could do to kind of try to make people keep their promise or cope with the fact that they can't keep always their promise and have a different route, create an option. So we have the ideal situation and the promise people are making to us. So in the ideal world, they will say, we're all secure, we're all helpful, we're all aligned with your goals. So Tom Menz actually created a metric called technical lag that it could be used to show how far we are from the ultimate promise, that everybody's aligned on the same thing. And it is looking at what is the delta between the ideal version and between the current version. And the idea is that the part in between is a technical lag. And technical lag, or the difference, can be measured in different ways. It could be measured in time, like it's like 2 days old, 5 days old between the different releases. It could be versioned, like it's like one major patch, one patch away from the current version, or it's like 2 vulnerabilities away, or it's like 7 bugs away. It might not be a bug, might not be a vulnerability, but a feature problem. So this gives us a measure of looking between the ideal and not ideal. We could apply it to containers, we could apply it to SaaS versions, we can apply it to anything that is built in incremental versions where we can say before and after something was ideal or is the current version. And so part of the metrics you can measure is, besides just the number of dependencies, you can look at like the whole dependency lag, inclusive the deployment lag. So it's not just them delivering, that might be the outside CI pipeline that you don't have control of. And then there's the deployment lag that you have on your own systems. An example usage of kind of a very simple use of this metrics is libyurn. It shows you, it counts like the number of years between the software versions, and then it gives you that like in lib years. A simple way, powerful way, like how many lib years are you away from the ideal situation? It might not be years, might be days, I hope for you, but it's kind of a very interesting metric to work to. And now that we kind of are able to measure somehow the difference between the ideal and non-ideal version, is we can use that in a policy. And in this presentation, the people from Pivotal kind of used that a similar way to define a vulnerability budget. It's hard, it's very, mimicking the error budget, which has become popular with the SRE. It's like how many vulnerabilities, how many outdated dependency do you actually allow? And then you make that window, for example, you need to patch every 30 days or maximum 30 days, everything needs to be patched. So there cannot be like an accumulation. And, we all kind of have this, it is an assumption and it isn't always true, but the more and the faster we patch and the faster we get up to the new versions, the more secure we are. I showed you in the different ways of measuring the lag, whether it's like versions or features or security, you might have like different variations on what you think about the ideal one, but it is a common assumption that we're dealing with security as the most updated or like frequently updated will save you from being non-secure the most. And we can apply this same policy metric, not only whether we should update the patch or the bug or whatever, but like I said, also the runtime. In this case, they use like Kubernetes. Like how often should we update Kubernetes? Like, is it like it needs to be stable, but needs to be secure, and they need to find like a balance between both of them. So they have like this band where they say it's good enough and it's secure enough in between two versions. And what is really nice about this metric is that they not only show that, yeah, you kind of stay within those measures, but the fact that they mentioned that this was a way that the team could show value. So again, you might think of the vulnerability as a kind of technical metric, like how secure, how many patches have been done, but it's actually showing how good your team is performing at handling this. So again, it's actually the human part that you're measuring, just like your dependencies is depending on humans. And obviously, you know, how do you start? You know you have X amount of vulnerabilities, but you only know that if you're getting good at detection. There are several tools out there that help you in doing better detection based on libraries, kind of scoring, like public vulnerability scoring or static analysis. So there's a lot of tools out there that will help you detect more issues. But the interesting thing is that, like, what do you do if you have 242 high severity bug fixes and you're like a 2% that they are able to fix that? How do you deal with that? And in our survey, we showed that we're doing some testing, but a lot of it is still also manual, which is good, which is needed. You can't try anything with all the tools, because part of it is understanding the domain, and whether that's your vulnerabilities in general, or it is actually the tools, the maintainers that need to check things, they also benefit from the same thing. So we're not that different as our code, somebody else's code. We all need to check and get better at detecting vulnerabilities. And I'm not only talking about code in general. You can take, like, obviously there's code, there's infrastructure as code, and then there's almost like configuration as code. In this case, like Kubernetes, the Helm charts, everything is a library, like I said before, things that you can actually check for vulnerabilities and dependencies. And once you have that big bucket, then the real problem begins. And that's where a lot of the tools are starting to be less helpful, because you need to understand the system way more. So if you have a vulnerability, you might still know what attack vectors it does and how it operates, but you might have to look for the fact whether it's still applicable in your case. Maybe you have other controls in place, maybe it doesn't work on your side, maybe it's not that important, all balances that require you this triage. So a lot of the tools will go like very broad, but just to get all the vulnerabilities. But then the second phase triage is kind of like narrow it down to what applies to you and what you're willing to act on. And that brings up the problem, like, even after so many vulnerabilities and doing the triage, you probably have to allocate people to it. And there's no good strategy whether you're gonna do all the bugs, the easy ones first. You're probably gonna have like a balance between the easy ones, the ones you care most about, and working that. But figuring that out is a human thing. So it's not something technology can do for you, because that is taking the risk into account and so on of your current business. And a way of looking at that is something called the cost of delay, and it's used inside the SAFE framework. And it looks like, what if we do nothing, right? And if you do nothing and the exploit is never used, then we're at the optimum. If we didn't do anything and it got exploited, how much would it cost us? So the delay that we measured earlier between acting on it and not acting on it is also something you can use in the consideration whether you should act on it. Like, how much does that delay that we mentioned before actually cost? And if it has a high cost, then you probably want to take some actions. The delay of that cost is probably based on some profiles of your business. Sometimes it's okay. Imagine if you're only working 1 day in a month, right? The delay that it's found in between and there's no users, the cost isn't that high. But if everybody's at peak using it and then you have a vulnerability and there's a big leakage, then it has an urgency. So it's not only just looking at the number of vulnerabilities and the risk. The time is also, and the urgency is something you need to take into account. This is a graph of somebody making their own balance, looking at like, are we going to go with all the vulnerabilities in the list that the bug list provides, or only the higher? And they found like a good precision and recall somewhere around 7 and 6 of the vulnerability score. And that really helps them kind of get like a policy again, like should we act or not, like how much can we spend on that or not. And if you want to take into account like that your priorities are fixed, it's actually not the case. So imagine if you have a vulnerability and it's open and you thought about it, but if nobody's exploiting it, then it would be nice if you could delay. So it's almost if you, securability coined by Shannon Leeds here is, as you look in production what exploits are being done and you based on that. It's almost like a real-time re-evaluation of your priorities based on the risk they currently have. In our report again, we've shown that we have high expectancies of fixing vulnerabilities by maintainers. 8% thinks that we can fix them in a few hours, right? Imagine that. But on the other spectrum, some might take like 3 months to fix. So there's a big spectrum on how much effort and how much risk and how much they care about that. What we saw from our own research, if we nudge people that there is a vulnerability, we saw even 1% fixed the same day. But it might still take some time before everything gets fixed. But there's a good a trend upwards of fixing things right now. So we've shown about the delay that it could take. This is a nice way of visualizing this, like almost like technical depth of things that haven't been taken care of that you're aware of and you want to do better. On the top, you also see the tracks by severity so that the speed isn't the same by all the different severities. That is important on the urgency. In this next thing, Maxim actually explained that there's still subtle differences in risk and prioritization and delivery of speed. So in this diagram, he shows that a lot of the upper ones, they've been fixed quite fast. And some of the bottom, like redirects and forwards, they're very slow. And he attributes that to the fact not that they were harder to fix or kind of took more time or the risk was less. It was just that it wasn't on their priority list. Like there's a top 10 vulnerabilities to fix and that one was maybe 11. And so nobody kind of cared about that list because it was just trying to crunch through the number of vulnerabilities. And another finding he had that, like, while we might think that the speed of resolving something is related to the criticality, here in the middle he shows this -18 of something that was medium, but it was very easy to fix, and there were a lot of them bug fixed. Sometimes by using a framework, you could squat a lot of bugs. They're all over the code, they're all happening in different code bases, but you remove that to one library, and that library kind of has a good control to mediate that problem. And then all of a sudden, boom, you see these kind of efforts. So it's not that straightforward when you look at those kind of metrics. And I think Keeping the number of bugs low is not the perfect strategy because it will gamify it. They will solve like smaller bugs all the time, make the looking numbers good. So it isn't about chasing the bug that much. It's what he says. The shift left is that we want to control and put more controls in the designing the architecture, meaning like earlier, so that they don't happen further in the architecture. So all this re-architecturing is fine, but we can still go a step further, and we can even predict bugs, right? Or predict vulnerabilities. It sounds strange, and it isn't that much of a voodoo. It just takes into account that bugs are created by people, and people have limited understanding. So if there's certain areas in your code that are touched quite frequently, they might be a good indicator of them having potential security vulnerabilities. And if you're doing assisted code reviews, you might show that as this is a God class, look with care, and it's not because it's a God class because it has all the powers, it's a God class because everybody wants to be there in that place. So we kind of went from detecting, improving the detection, getting faster at the triage, and making fixing things faster. But we can also make more accurate predictions for automated fixes. So some things are just so easy, but that you can have a suggestion of like an upgrade or something. But without running tests, you don't dare to do that. And for example, the feature of merge advice would show you that multiple people have merged this automated patch, and it has a high degree of success because for all the others, the tests kept on passing while the update went down. It's not an absolute, it just, again, gives you some hint for the human to decide. In this presentation, we look at another kind of way of looking at the data. It is not just looking at the number of vulnerabilities that we have and keeping them in kind of bounds. It's like, how well are we doing? So if the number of bugs are going down, that's good. And the way the metrics manifesto talks about them is they talk about like escape metrics. How many bugs escaped staging toward production? And if you're measuring that in the beginning, there might be a high variance. And then over time, this will kind of, get closer to reality at a certain baseline. And what's interesting then about that is that you have a baseline you can improve on. So how many bugs are going through, how many things are doing. So a lot of the initiatives you would take to educate your users, to educate your people, you can baseline on that. And obviously you can rate them differently based on the vulnerabilities priority level. So this escape rate is like really a metric that you can use to measure kind of the progress of the people getting better at this vulnerability or security spotting. And he even plotted multiple teams where he looked at the mean on how many vulnerabilities each of them had and how many escape rates. And then you saw them converge and say, well, now all the teams are getting better. So a new team might be further off in the beginning, but they'll converge slowly to kind of like get better. And you can compare both teams and imagine if we could do that like across industry, across companies, then we will see that difference. But sometimes we've now shown that there's no evidence. If you can't detect it, you don't know it, but it might still be vulnerable. So be aware that we are having this state all the time, and sometimes we are in a state of being vulnerable, even if we know it, but we're not fixing it. And this brings me to the fact that a lot of the things we do in a pipeline is building up confidence. And it works today, it will work tomorrow. If we put these controls in place, we will get the same results or better results. But it's not actually doing trust. So sometimes I ask the question, what if you don't have your CI system anymore, or it doesn't work for a day? Do you trust the people to work on that? part on the pipeline and to make the correct decisions. And there's something called the ironies of automation, is that we automate a lot in the pipeline, and that's good, but we can make actually problems in a way that we might be getting worse at understanding what's happening because the tools are doing something, and we're just saying, well, trust the tool, it's doing its thing, and the system becomes its own thing. And you have to be aware that this kind of whole idea of automating, you kind of still have to have the knowledge to operate it, because if it fails, it's the human task in the design of the system that needs to verify whether it's working correctly. So that's something that you really want your humans again to work on. Think of it like, you don't want to think about your car while you're driving, but when it fails, you want to understand how the engine works, because otherwise you're helpless. Very similar kind of way of thinking. And John Oswald brings up an interesting metric, is like how long can your system survive without human intervention? Is it like a week, a month? Like, is there, I think it's in any case that I've heard of, there's always humans dealing with part of the problem, and it's never going to be completely automated in that. So it boils down to, coming back to our dependency problem, is that the humans, they're the ones you trust. The CI system is one you have confidence in when it works, but you need to build that trust across your team, across your company, to make sure that they're delivering secure things as well. And the way that I look at it is that we're all dependencies. Yes, we looked at upstream dependencies, but we too are dependencies. And in the whole idea of DevSecOps, we want the dependencies to be reliable, sincere, competent, and care, much like we want the library to do. And that means like coming to a sprint planning, get better at security practices, and so on for security people. And then for developers, they want security to be, understand that there's a balance between not only the latest secure version, but also the one with like features, and kind of having this conversation and making this balance is important. And the takeaway would be is that we look a lot at how others are trustworthy or not, but I think DevSecOps is about us becoming trustworthy to others, and others depend on us, and that is part of our job. And in that way, building a trust in a service is no different to a person. So you want to have transparency and communication, and by that you will see the 4 quadrants, whether they keep people their trust or not. And so I think technology amplifies the human forces. It is not the other way around. As we've shown, there's a lot of human interaction. Even though we might do a lot of automation in that part, there's still a lot of human decisions that need to be taken. So in my opinion, is human trust enough? No, but in many cases it's all we got, and that these situations are still plentiful. So not only invest in your automation, automating your people so you can make sure you can trust them as well. So this was my presentation. I appreciate you thinking with me. This is not the most polished like 1, 2, 3 presentation. I borrowed a lot from other people, so do explore that. But I hope it gives you some ideas to explore and how you better can measure the human trust that you're putting inside the system. Thank you very much, and I look forward to your questions right now.